Hello everyone. Today we will discuss the Python code for computing the greatest common divisor of two integers. So, as per definition, what is a greatest common divisor? Greatest common divisor of any two given integers which are not all zero is the largest positive integer that divides each of those integers. So let us take an example, and we are going to demonstrate this Python code using the Euclid's repeated subtraction method. So this program is based on the Euclid's repeated subtraction method. So let us take two integers, call them a and b, and the values, let us take it as 24 and 20. So a is 24 and b is 20. So the method proceeds like this. So if a is greater than b, then b is getting subtracted from a. Otherwise, if b is greater than a will be subtracted from b. You keep on repeating this process till both the numbers become equal. The moment both the numbers becomes equal, that number is the greatest common divisor of those two integers. So this is the logic of Euclid's repeated subtraction method. So the number a is 24 and b is 20. The values for a and b are 24 and 20 respectively. So in the first iteration, 24 is greater than 20, that is a is greater than b. So you're going to subtract 20 from 24. So the value of a becomes a is equal to a minus b, that is a is equal to 24 minus 20. So a became 4 and b retains the value. Now once we move on to the next iteration, we are again checking if a greater than b. No, in this case b being 20 and a being 4, so b greater than a. So b is equal to b minus a. So 20 minus 4, so b becomes 16 and a retains its value. Now in the next iteration, we are checking whether a is greater than b. Here also it will b is greater than a, so b becomes b minus a. So 12 minus 4, the value of b is 8 and the value of a is 4, that is retained. Now in the next iteration, again we are checking whether a is greater than b, but here also b is greater than a, that is 8 is greater than 4. So b is equal to b minus a, 8 minus 4, b. So in the next iteration, we are checking if a greater than b. Now at that point, both the numbers are equal, so you stop iterating and you return that value. Whether you return a or b, it is the values are same, so you can either return a or b. So 4 being the GCD. So this is the method by which we compute the greatest common divisor of two given integers using Euclid's repeated subtraction method. So if you look into the number a, the divisors of a are 1, 2, 3, 4, 6, 8, 12 and 24. The divisors of b are 1, 2, 4, 5, 10 and 20. And what is common is 1, 2 and 4, and the greatest among these is 4. Right, so the process is correct. So let us go to the Python code. So as usual, we start with the single line command depicting the purpose of the program, that is write a Python program to find the GCD of two integers. And it is very clearly stated that the methodology what we are adopting here is the Euclid's repeated subtraction method. First, we are accepting the value to the variable a. So we use the input method and that is being typecasted to integer. So a is an object of class integer, and similarly b is also an object of class integer. So b is holding the second number. So the first number and second number are accepted from the user and being stored in two variables a and b respectively. Now we are making a copy of a and b to x and y. So multiple variables could be initialized in Python. So the format is the variables separated with commas equal to the assignment variables separated with commas. The only thing what we should be taking care in this case is that the number of variables in the left hand side should match with the number of variables in the right hand side. So here the value of a will be assigned to x and value of b will be assigned to y. So this methodology makes the code very compact. Now we did make a copy of these variables because when we do the repeated subtraction, the value of a and b will get changed. So once after computing the GCD. If you want to give a message like the GCD of the given integers, the numbers you want to print it, that time you would have lost the values. One workaround is that before you start with it, you can give the print message here before we start with it. That is also an option. So uh, we start with the process, that is we are checking whether either of the values is equal to 0 or a negative number by this conditional statement, that is a less than or equal to 0 or b less than or equal to 0. Since this is a logical or, any one condition turning true will make this condition true. So then we, if it is true, we give a message that GCD is computed for positive integers only. So if both the numbers are greater than 0, we'll come to the else part, and we keep on iterating till both the numbers become equal. So in the previous example we already demonstrated, let us take the value of a is equal to 24 and b is equal to 20. So 24 not equal to 20, and we are checking 24 a greater than b, that is 24 greater than 20. Yes, so a is equal to a minus b. So that point the value of a is becoming 4 and b is retained with 20. Now again going back, we are checking 4 not equal to 20. Yes, we got inside, and we are checking whether 4 greater than 20. No, so it will come to the else part, and b is equal to b minus a. So here in this iteration b will become 16. B is I will write the value here. B is becoming 16 and A is having the value 4. Now when back, we are checking 4 not equal to 16, true. So we can iterate again. We got inside the loop. We are checking 4 greater than 16. It's false, so we'll come to the else part, and B is equal to B minus A. So B will become now 16 minus 4, which is 12. When back, again we are checking A, the value of A is 4 and the value of B is 12. So 4 not equal to 12, true, got inside. And we are checking whether 4 is greater than 12. No, so we'll come to the else part. B is equal to B minus A, that is 12 minus 4. So this will become 8. Now again went back, and we are checking whether 4 not equal to 8, true. So we get inside the body of the looping statement. Then we have the conditional statement, whether which is checking whether a is greater than b, 4 greater than 8. No, so we will come to the else part. B is equal to b minus a, that is 8 minus 4, and here it becomes 4, 8 minus 4, which is equal to 4. Now when back, and we are checking the value of a is now 4 and b is 4. We are checking 4 not equal to 4, but 4 is equal. So at this point it is turning false. So you stop iterating, you are coming out of the body of the loop, you come out of the loop. And here once we reach out, this is the next statement. So we are printing GCD of x and y. So we have already made a copy of a and b into x and y, so it will print GCD of 24 and 20 is 4, right? Okay, so the values got computed correctly. So this is one method, and let us just execute this code and see how is it working. So enter the first number. So let the first number be 24. Enter the second number. See, it is GCD of 24 and 20 is 4. So we got the answer correctly. So again, one more time we can enter. We'll give a value which is 0 and another number. So it is stating that GCD is computed for positive integers. Now there may be a negative number we can give, and we can give 20. So here also it is giving us the result properly. Now there is another method. The second method is also demonstrated. The second method is using the built-in function. So the code becomes even more compact when you use the built-in method. So here what we have done is that there is a built-in method for computing a GCD of given two integers in the math module, and that method is called as GCD. The method name is GCD. So since we have to use the GCD method which is there in the math module, we import the math module using the keyword import. So we import the math module, import math. Then you accept the first number, into A and second number into B, and we are checking whether they are positive integers. If either one of the value is 0 or lesser than 0, we will give the message that GCD is computed for positive integers. Otherwise, if both the numbers are greater than 0, we will come to the else part, and we are going to compute the GCD by invoking the GCD method which is there in the math module. So the format of invoking the method is the module dot the method, the parameters. So math dot GCD A B. So here let us say you give the value of A as 24 and B as 20. So here this gets translated into math.gcd of 24 comma 20, and this built-in method will return the GCD back, which will be 4. So let us just execute this and see. So this is equal to 24 and this is equal to 20. See, it gave the correct answer. So one more time, maybe what we can do is that we will execute it with the negative value, -1 I will give, and 20. So it is telling that it is computed only for positive integers. So the two methods are demonstrated. One is using the built-in method and other one is using the Euclid's repeated subtraction method. Hope you have enjoyed learning this algorithm for computing GCD. So wishing you happy learning. Thank you for watching.